So in this section, I'm going to show you how to solve systems of equations using what's called the inverse matrix. So we have to figure out what is an inverse matrix. We do have to do a 2 by 2 matrix inverse by hand. That'll be on the non-calculator piece to your test. 3 by 3s, I'll show you how to use your calculator for those. When you start with your systems, the first thing you always want to do is identify what is your A matrix, what's your B matrix, and then we'll solve for the X matrix. Your A matrix is always the coefficients that are in the fronts. 2, 3, 4, 5. So we have to write down what our A matrix is. Our B matrix will be made up of the answers. So our B matrix is the 2 by 1 matrix, 8, 20. And then the X matrix, this is our unknown matrix. This is what we're trying to solve for. When we get our answer, it will be in a 2 by 1 column format. Two numbers will be x, y, which we can then translate into our ordered pair x, y. Usually when we look at a system, just like we look at an equation, we're going to do a times x equals b. Our job is to solve for x. But with matrices, we cannot divide. There is no such thing as division with matrices. So just as if I were to tell you 4 times x equals 12, how would you solve for x? You would say divide by 4. But what if I told you that there is no such thing as division? Well, dividing by a number is the same as multiplying by the reciprocal or multiplying by the inverse. So what we could do instead is multiply by 1/4, and we would do that on both sides. That's the way that we'll get that number out of there. And then x will be equal to 1/4 times 12. We're going to do that exact same process with matrices. There is no division with matrices, so instead of dividing by A, we're going to multiply by the inverse of A, and that notation looks like this: A raised to the minus 1, but don't say A raised to the minus 1. Say inverse matrix of A. So for us, this is our formula right here that we will need. The unknown matrix X will be found by taking the inverse matrix times B. This would be a good one to put on your cheat sheet, by the way, for your final. Okay, so here's our way we're going to get these. We have identified an A matrix. It'll be the numbers A, B, C, D. The inverse matrix must be found by doing this first. We're going to make a scalar multiplier in the front, 1 over the determinant of our A matrix. Determinant, remember, is going to be AD subtract CB. So that value is going to go on the bottom. We're going to use that as a scalar multiplier, 1 over the determinant. Then we're going to times by, and here's where it gets kind of weird. We're going to take our original A matrix. We're going to look at these two places, this first diagonal. We're going to swap places. So the D comes first, and then the A comes underneath. So take your first diagonal, swap places. Now the other diagonal is going to stay exactly where they're at. The B and the C values are going to stay where they're at, but they are going to become negatives, the opposites of what they started as. So you need to negate each of your two pieces on that one. Then you will carry out the scalar multiplication, and that will give you your answer for the inverse matrix. All right, let's try a simple one right here. We have the matrix 2, 1, 4, 3. Our determinant, 6 subtract 4. Our determinant is 2. So the inverse will be found by doing 1 over 6 minus 4. So it'll be 1 over 2, 1/2, times by. Then we took the first diagonal, 2, 3. We traded places, 3, 2. Leave the other diagonal, 1, 4. Leave them where they are, but make it -1, -4. Now we can carry out the distribution. And I'll just rewrite this here quick. 1/2 times 3, there's 3/2. 1/2 times -1, 1/2 times -4, and 1/2 times 2. So there's your inverse matrix. 1.5, -1/2, -2, and 1. So how do we use this inverse matrix to solve a system? Here we have an equation. 2x plus 3y equals 8, 4x plus 5y equals 20. First thing we always do, identify your A matrix. 2, 3, 4, 5. The determinant of that, 10 minus 12. Determinant is -2. My inverse matrix, 1 over my determinant, 1 over negative 2, times by, now, take your original matrix, switch places, 5, 2, leave 3 and 4 where they are, but make them negative, negative. Now carry out your distribution. Negative 5 halves, positive 3 halves, positive 2, negative 1. This is our inverse. Now when we solve the system, the unknown x matrix will be found by taking the inverse matrix times b, my inverse matrix again. Our b values were the answer numbers, 8, 2, and now we can go ahead and do our multiplication. Negative 5 halves times 8, there's negative 40 halves, negative 20. Slide over, slide down, 3 halves times 20 is 60 over 2, that's 30. Negative 20 plus 30, 10. There's my x number. Next row, 2 times 8, there's 16. Slide over, slide down, negative 1 times 20 is negative 20. 16 minus 20, negative 4. There's my y value. So the solution to my system is 10, negative 4. Let's try this one. 2x minus 3y equals 10. Negative 5x plus 8y equals negative 26. A matrix. 2, negative 3, negative 5, 8. The determinant of A. 16 minus 15. That's handy. My inverse matrix. 1 over my determinant. 1 times by. Take the first diagonal and swap places. 8, 2. Take the other diagonal, leave them where they are, but change the signs. Do your scalar multiplication. I'm only multiplying by 1, so my answer just remains 8, 3, 5, 2. Now the inverse matrix will be taken times b. So solving for x, I'll have x equals my inverse, 8, 3, 5, 2, times my b matrix. Our b matrix is these numbers right here, 10, negative 26. 8 times 10, 80. Slide over, slide down. 3 times negative 26, negative 78. 2, that'll be my x. 5 times 10, 50. Slide over, slide down. 2 times negative 26, negative 52. 50 subtract 52, negative 2. My solution should be 2, negative 2. Or you could write it this way. X equals 2, y equals negative 2. Finding a 3 by 3 inverse, I'll let you do on your calculator. Your a value, 1, 0, negative 2, 3, 2, 1, negative 1, 1, 4. We're going to find the inverse to this. You're going to go to your calculator. So here's your commands. I'll show you these steps and then I'll bring up my calculator. You'll go to your matrix button. You need to edit. So call your A matrix 3 by 3. Put your numbers in. When you're done, you could do second quit. Then all you have to do is pull up matrix A again. And then if you look on the same button that your matrix button is, it looks like x to the minus 1. That's the inverse button. All we have to do is take A and then hit that button and hit enter, and it'll calculate the inverse for you. Sometimes you may need to change from icky looking decimals into a fraction, and you can do that, and then you'll have fraction numbers. Okay, so I'm going to show you how to pull that up on your calculator. Okay, so we're going to go to our matrix button, second matrix, arrow over to edit, choice number 1. It is a 3 by 3. Now we can go ahead and enter in our numbers. 1, 0, negative 2, 3, 2, 1, and negative 1, 1, 4. Always double check your numbers, make sure you didn't type something incorrectly. Once you have your numbers in, second quit, pull up your matrix, Choice number 1 is A. Just hit enter. Now you're going to hit that inverse button. That's the same button as your inverse, or excuse me, same button as your matrix, but don't do second matrix, just hit that button, x to the minus 1, and that's how it shows up. A to the minus 1, which we actually say is inverse matrix of A. Now just hit enter. There's your matrix. Now you see we've got ugly decimals here. We want to see what these look like as fractions instead. Go to your math button. Choice number 1 is fraction. Hit enter. Now it takes our ugly answers, changes it into a fraction, hit enter again. And there's our inverse. Negative 7/3, 2/3, negative 4/3, and so on. I will now just transfer those onto here. Negative 7/3, 2/3, negative 4/3, 13/3, negative 2/3, 7/3. There you go. There's your inverse matrix for 3 by 3 done on your calculator. All right, so that's it for finding an inverse. Please put the inverse matrix stuff on your cheat sheet. I'll talk about it again tomorrow as well. And then in the second half video of 3.8, I'll show you how we can solve word problems with the inverse and using our calculators as well. Okay, that's it for the first half of 3.8.